Let me know if it stops. Cool. All right, guys, so let me ask you this. Let me see. Is there something you would like to know about, like, Grossmont students in general, so you can kind of compare yourself? Like, we could do something like the percentage of Grossmont students who smoke. Do you understand? Yes? Oh, okay. So the percentage of Grossmont students who are going here and also working. So how many guys currently do not, well, let me say this. How many guys have at least one job right now? Okay, I like it. I had like 3 jobs going through college because I was paying my own way. Anybody do the FAFSA? And I love it when they say family contribution at the top, and I'm like, my family can't contribute shit to me. No, you're wrong. So, I had 3 jobs, went uphill both ways, all that kind of stuff. So I understand totally about having a lot of jobs. My report card, I like to say it had a lot of personality. Because I wasn't always able to do all the homework, all the projects. My main focus was, do I understand what's going on? So I always lost points because I couldn't finish all the homework, I couldn't finish all the projects because I was working 3 jobs just so I can go to school in the first place. So I totally understand that. Yeah, a lot of personality. So let's say we want to know the percentage of Grossmont students By the way, yes, I write this horribly. I'm not doing it on purpose right now. We want to know the percentage of Grossmont students who also work. Woo! Now, at least I don't write as bad as one teacher that when somebody said, "What did you write on the first line?" and they're like, "Does somebody remember what I wrote the first line?" I can at least read my own writing. Okay. Somebody with me so far? It could have been anything. We want to know their average left foot size or whatever. That would be a very strange, specific thing to know. How do we go about figuring this out? I love it. So a lot of us already know some basics of statistics. It's all about taking a sample, right? And very often we can identify a sample very easily, but we have trouble with the other word that's associated with that. Where do you take a sample from? Population. I love it. So, for example, somebody tell me one way we can get a sample.
Survey.
Survey, okay. But you're not quite with me yet. That's how you ask a question to the sample you've picked. How do you pick the sample? Or are you just going to give it to blanket everybody and just see who turns it back in? Now, let me talk to that real quick. If you gave a survey somehow to every Grossmont student and just counted those who turned them back into you, is there a problem with that?
Yes.
Can you trust your results? Because why not? That doesn't matter. Let's say I give it to all 20,000 Grossmont students and 900 reply. That's a good sample size. Well, what's wrong with that? Yeah, I love it. They're more opinionated. There's going to bias my results because there's some reason that they gave the back to me and the other people didn't. Does that make sense? So my results are going to be biased in that direction. I like it. Maybe. Yes?
So just do like research on the whole class and maybe like the whole math students and the whole math class.
So you can take all students who are taking a math course?
Yeah.
That kind of thing? So again, would that have some kind of possible bias? Because there are certain students who don't have to take any math, and there might be something about them that actually affects the answer to this question. Do you guys see that? Even if you can't possibly imagine anything that would do that, it's still not a good enough sample because it's specific. It's a specific group, and they might have some kind of bias.
What about the chance that, say, 800 of the people who turned it in were male, 100 female?
Yeah, okay, you can always worry about proportional sampling. We're going to get into that a little bit to make sure you hit certain groups with getting a correct enough information from them. It's sort of like that study they did, a committee on women's health, and it had nothing but men on it. right? That kind of thing. It's kind of like, okay, who thought about this, or did you think at all? Yeah.
Isn't there like different kinds of people who bring in the same thing and just stand outside of class and hand it out, or you can do it the third person in every row?
Oh, I like it. So some of you guys already know some of the different kind of sampling.
Can you just stand in each parking lot, pick 150 people from each parking lot, and interview them right on the spot?
All right, now who are you leaving out? People that walk here or take the bus. But I'm not complaining. That's a beautiful idea. I like that you thought about every parking lot. Now you also want to do. You would want to do that at several different times, over several different days. You guys with me?
Yeah.
But do you understand what I'm trying to control for? If I only do it on a Monday, then what about the students that only come on Tuesdays? You see what I'm saying? So there's all these things you want to account for. So what's a really basic way to come back? Let's say that we have access to the computer system, and you all have student ID numbers, right?
Yeah.
So what could we ask the computer to do for us? Randomly pick out student ID numbers. Now somebody emailed me a very interesting about the TI's inability to really be random unless you kind of do it correctly. Creating random numbers is a remarkably difficult thing to do. But we'll see about that. But let's just say, and somebody else was talking about every third person. So you can have the computer print out all the student ID numbers, and you take every 20th one or something. Do you guys understand? So what is it I'm trying to do, though? What was it about only picking people that are taking a math course? Why is that fundamentally not good enough? Good. Not everyone needs math courses, so what are we always trying to do? I want my sample to represent, I want it to have the variability that the population has. And what's the best chances I have to do that? I want everybody in my population to have a chance to be in the sample. So anything I do that excludes groups of people, I automatically cannot trust. I might get the best sample in the damn universe, just accidentally. But if I excluded groups of people that I picked from, I can't trust my results.
Well, you know, like at the end of semester, sometimes I would have you do like a survey on a teacher, like maybe you do a survey for each class. Like,
I love it. But this is us. And we don't have those kind of resources, right? So I'm talking about poor little us. We don't have the resources or the access to do that. You with me?
Yeah.
But that would be the best way, of course. But this is just us. We're interested in the administration's like, whatever. We're not going to do that. So let's say this. Let's say that we get a list of all students, and we pick every, let's say 100 students. Now to really make that random, I would say the first student I pick is randomly chosen, and then I do every 100th after that. Are you guys kind of with me? Because then you can say, if I pick you, and then I skip you, you would never have a shot. But if I randomly start somewhere in that first row, then everybody's got a shot in the whole room. Now notice, for some reason people say, if I say you, and then the 1, 2, 3, 4, you, and then 1, 2, 3, 4, you, and then somebody says, well, you didn't pick her. I don't care. Does she have a chance to get in? Yes. That's the key. Does everything or everybody in the population have a chance to get into the sample? That's a good sample. Like, is it possible that you just picked all the people that work a lot? Is it possible that you picked everybody that works a lot? Of course it's possible. So we're always trying to control for that to not happen as often. And the best way to do that is to make sure everybody has a chance to get in. All right, maybe. All right, so this is my sample. Now, what must my population be? My population here is really simple.
All the students at class 1?
Yeah, all the students at Grossman. So in general, the population is the collection of everybody or everything that you want to say something about. The sample is a subgroup of that population that you're actually going to analyze. So if you can identify the sample, you must be able to identify the population. You say to yourself, where would I pick this sample from? And that's the population. So if my sample was 78 people from Wisconsin, what's my population? All people from Wisconsin, right? I like it. So very often you can just replace the number with the word all. That will happen a lot also. Okay. So that's my groups. Everybody I want to say something about, and everybody I'm going to actually work with. I like it. Now, this thing that we want to say about people, the percentage of gross plus students who also work. This is the problem with using a sample. If I can only use a sample and not the entire population, will I ever be able to say something specific about the whole population? No. But this is what's called inferential statistics. I want to infer something about everybody from a subgroup, from the sample. And why do we have to do that? Because very often the population is way too large, right? Do any of us have the time or resources to talk to every single gross one student? Hell no. But I can talk to a subgroup of students, sure. I like it. So we have what's called the, let's see, how do I say? Well, let's do it this way. What question would you ask? Now we've got our sample picked. What question would you ask?
Job.
I love it. Do you have a job? I like it. Now this, and then give me a possible answer. Is there a slightly different question we can ask that would actually let us get even more data that we might use later?
How many hours do you work in a week?
I love it. 0 to whatever, right? 0 to crazy. I like it. You guys kind of with me so far? If they say 0, they obviously either don't have a job or they're not going to have a job because they ain't showing up nor. That could be a problem. All right, maybe. Now, the question that you ask is related to something called the variable. Now, why does that make sense? What is a variable in algebra? Give me the variable that we always use in algebra pretty much. X, I love it. And what are the answers that variable could have? Like real numbers, right? So I'm talking about just basic algebra. X plus 1 is 3, so X is 2. Woo. So the question is X, and the answer in that case would be 2. Right? So it makes sense to call the question the variable, because how many answers could there be? So like this question, for example. A lot, right? I could have some weird person say, I work 29.73469 hours. Oh, okay, sure, that's fine. Right? Wouldn't that be fine as an answer? I'd look at them strange. But then I move on. Okay, I like it. So that's the variable. This is the data. The answers to the question are the data. I like it. I like it. Does this make sense so far? I mean, you know a lot of these words. You know a lot of these ideas already, which is nice to ease us into this whole thing. Okay. So this is kind of related to the setup and what you do with the people that you pick. Now, what do we actually do with the data? Let's say we're doing this one, right? What would you do with that data? Specifically for this. All right, you can find the mean. I love it. That's the reason why I like this question, is because it answers both things. I could do more with this if I was more curious. Sure, you could find all kinds of numerical stuff, right? But going back to this, what would we do?
Just compare your answers to how many people you actually are. How many people?
Yeah, how many people said 0, or how many people said no, I don't have a job, versus how many people there are. I can figure out the percentage, right? So then I would calculate the percent from my sample. I like it. All right, we good? Yeah, of course I would, Jeff. That's the freaking thing I'm curious about. This is what's called, believe it or not, this is what's called a statistic. This is if you actually, the thing you do with the data you gather from the sample is the statistic. Notice how the word sample and the word statistic both start with an S. Ain't that some nice shit? It's like, come on, math, do that more often, man.
Is that because the statistic is only applicable to the
Exactly. So a statistic is a numerical characterization of the data, of the sample data. I like it. So let's say I had 8 people. Well, how many people? I don't know. Let's say I had 1,000 total people, and I had what do you got, Jeff? 207 said no. So what percentage of the people work? Because that's the question, right? Almost 80, yeah. So 793 people said yes. So 79.3% of who?
Of the sample.
Of the sample. So that is the statistic. Now, anybody at all pay attention to the election last year? Anybody pay attention? Anybody accidentally pay attention? Yes, okay. Anybody notice at the bottom when they were saying, looks like 48% of people will vote for Clinton, and good Lord, Jeff. Well, that's Clinton. And 42% will vote for Trump, and poor Gary Johnson and everybody else. It's like, yeah. But at the bottom, very often at the bottom of the screen, they say plus or minus 4%. Normally it's 4. It just happens to sort of work out that way. That number will change depending on how big the sample was they used. If they use a larger sample, what do you think is going to happen to this? It's going to go smaller. It's the error. So the error should get smaller if my sample is bigger. In fact, if I talk to everybody in the United States, my error should be 0. Right? All right, maybe. Because I know everything, right? We'll actually be able to calculate this later this semester based on the sample size and some other things.
Like that means about 4% didn't vote?
No. This means that it's 48%, give or take 4%. So what could Clinton's percentage actually be? 44 to 52. And what could Trump's be? 38 to 46. Yes, 40. I got you. I'm with you. I was worried about you for a minute, but then it's more me. I understand. So, when people see this, what do they think? They think, well, Clinton's going to win this shit. Right? But, this is real life. This is math saying, I don't care if you want to know what's going to. I don't care if you want to know the lottery numbers. I don't care if you want to know exactly the chances you're going to be. Are you going to be hit by lightning? Yes or no? No, that can only give you this. Well, we think is about a 2% chance, give or take. I love statistics for that reason. That's why people give up on statistics, because as a human, I want to know. Well, what's going to happen? What's going to happen? And stats is like, I don't freaking know. Shit. Does that mean that stats has no use? Of course it doesn't mean that. It just means that you have to look at it correctly. And people look at it so wrong. So a lot of people saw this and were like, well, Clinton got this shit in the bag. Yeah. And they forgot, oh crap, there's some variability here. I like it. In fact, if you look at Gallup.com, is one of my favorite websites. Anybody know Gallup.com? All right. They'll actually explain to you the sample size, how they did it, who they might have excluded, how did they correct for possible underrepresentations, all this kind of stuff. It's really neat. There's a lot that goes into it. You guys kind of with me a little bit? All right. I don't know what got me off on this one. So that's the statistic. So now I want to say something about everybody, and that's what this would be. This is my best guess for everybody based on what I saw in my. This is what they saw in the sample. This is what they could say about everybody. Somewhere between 44 and 52%. You guys understand? So who is it that I actually want to say something about? So far we've said something about the sample, but who do I want to say something about? The population. And what do we hope the first letter of the word is for the one that goes with the population? We hope it's the letter P, and it is. It's amazing. I know, you automatically assume math is going to be evil. So if I want to say something about the entire population, that is what's called a parameter. Parameter is the exact same thing as a statistic. It's a numerical description, but it's of the population. So if I said 28% of Grossmont students enjoy stats homework, is that a parameter or a statistic?
No, parameter.
Parameter, because I said of Grossmont students, right? And the word all would be good. That's a dead giveaway if they use the word all. Right? But if I say 32% of students who take morning stats classes like stats homework, that is a statistic. It's of a sample of the population. Are you guys with me? I like it. I like it. Don't let that homework be hard. Right? Statistic, sample, parameter, population. You gotta love that shit. Okay. All right. Now I'm gonna make sure I'm not gonna. Oh, good. We can go into that. You want to take a little break? Sure. All right. Let's take a little break. Let's take a break for. Let's do 20 minutes. Yeah. So be back 5, 10, 15, 20. About 5 before 11. I'm gonna start talking again. Yeah. Sure. Yeah.
Where is it at?
Oh, I'm sorry. Yeah, it's down this way. I'm sorry. I was like, you can do whatever the freak you want to for 20 minutes.